This is a presentation about the Bermuda Triangle and the math behind the sides and the angles. This is presented and done by Yasmin Torres and Andrea Ricobono. The Bermuda Triangle is located off the southeastern coast of the United States in the Atlantic Ocean. The area is bounded by Miami, San Juan, Puerto Rico, and the North Atlantic island of Bermuda. There was once a man named Vincent Gaddis. Vincent Gaddis wrote an article on the Bermuda Triangle, and he was the first one to give it its catchphrase as the Bermuda Triangle. He's the first guy to name it that. In this article, he claimed that there were missing ships, and he also claimed that there were missing planes without any explanation. This led people to believe that there were strange activities going around in that area. The Bermuda Triangle was not particularly discovered, but Vincent Gaddis was the first one who put this area under examination. These are a few images of the strange activities that took place in the Bermuda Triangle. Like I mentioned earlier, activities included shipwrecks and a number of plane wrecks. Now we will describe the side lengths of the Bermuda Triangle. From Miami to Bermuda, this side measures 1,035 miles. From Miami to San Juan, Puerto Rico, this side measures 1,033 miles. Finally, from San Juan, Puerto Rico to the island of Bermuda, this side measures 954 miles. The angle at Miami measures 54.9 degrees. The angle at the island of Bermuda measures 62.42 degrees. And finally, the angle at San Juan, Puerto Rico measures 62.63 degrees. When looking at this as a triangle, we can label the sides A, B, and C. When looking at the area as a normal triangle, we can describe side A as 954, side B as 1,033, my bad, and side C as 1,035. Well, you know what I mean, right? Yeah, I said the number wrong, but you know what I mean. And anyways, angle A would be 54.9, angle B would be 62.42, and angle C would be 62.63. Sorry. The two trigonometric concepts that we'll be focusing on in this lesson are the law of sines, the law of sines and the law of cosines. First, we'll talk about the law of sines. The formula for the law of sines is a ratio. Sine A over side A equals sine B over side B, which equals to sine C over side C. As you can see, all of these sides must be corresponding to each other. So all the sines have to be on top, while all the side measurements have to be on the bottom. This is all ratioed equally in the law of sines. In reverse, when looking for reciprocal, side A goes over sine A, which equals side B over sine B, which then equals side C over sine of C. This is the same thing. All the sides, the little variables, have to be on top, while all the sine angle measurements have to be on the bottom, so they could all be equal in ratio. Next, we have the law of cosines. Once again, this is the law of cosines. The law of cosines goes, like I said, the law of cosines goes cosine A equals B squared plus C squared minus A squared over 2BC. Cosine B equals A squared plus C squared minus B squared over 2AC. Finally, cosine C equals A squared plus B squared minus C squared over 2AB. The law of cosines is used to find your angles of cosine A, cosine B, and C. So for law of cosines, usually you need to have all your side lengths in order to find your angles.
Now we're going to do exclude an angle and a side measurement so we could prove the Bermuda Triangle. Okay, now that we have all the sides and are only missing the angle of Miami, we have to find it by doing the law of sines. Okay, so the formula for sine is sine A over A equals sine B over little b. So assuming that Miami's A, Bermuda's B, and San Juan is C, we would assume, and 1033 is B, 945 is little a, and 1035 is little c. We would do the portion for sine A, which is x, over 945, equals sine B, which is 62.4, sine 62.4, then 62.4 over side of B, which is 1033. Then you cross multiply, so it would be 954 times sine of 62.4 equals sine A over 1033. So when you multiply 954 times sine 62.4, you get 845.438 equals sine A times 1033, and then you would divide the 1033 and divide the 1033, and you would get 0.81842 equals sine of A. So you would do second sine, and proving it would be A equals 54.9 degrees, which proves that the law of sines works. Okay, now we're going to do a side. Now that we have Miami, which we proved was 54.9, let's assume we don't have side 1035. And let's prove with law of sines what side C is. So this is C. Okay, now let's plug in numbers. So sine of A is 54.9. Little a would be 954 equals sine C, which is 62.6 over our missing side. Now you would cross multiply, so it would be 954 times 62.6 equals sine 54.9 times x. Now you would divide over the sine of 54.9 divide over the sine of 54.9, and do the actual math. I'm sorry, this is supposed to be sine of 62.6. When you multiply 954 times the sine of 62.6 divided by the sine of 54.9, you would get 1035 for side C. Okay, now we're going to assume that we don't have the side of 62.4 for Bermuda, and we're going to do it with the law of cosines. The law of cosine, the formula to find angle B, would be cosine B equals A squared plus C squared minus B squared all over 2AC. Now plugging in the numbers would be 954 squared plus 1035 squared minus 1033 squared all over 2 times 954 times 1035. And this equals the cosine of B. Working through the problem, you would get 910,116 plus 107,122 minus 106,7089 all over 197,4780. When you divide this and add and subtract it, you would get cosine of B equals 0.46296. And then you would do cosine then you do second cosine of 0.46296, and you would get angle B equals 62.4 degrees. And proving, going back to our other triangle, this proves that all of the angles, by doing the cosine, law of cosines, and law of sines, equal the real Bermuda Triangle. And that's it for our project on the Bermuda Triangle.